Right, these notes are going to go through the second method for systems of equations, and that's known as the substitution method. It's going to look a little weird to you and sound a little weird to you until you get the flow of the steps and understand everything that's going on with them. All right, for every method, I will give you the steps for that method before we practice any examples. So the first thing I want to take the time and do is write down the steps for substitution. They are going to sound foreign to you, but just write them down, and then I promise that I will explain them as we go through the examples, and it should make more sense once you see the examples happen. Right, but the first step that you're going to have to do is to solve one or, sorry, not one or, but one of the equations for one of the variables. And it does not matter which one. All right, so what you're going to be looking for is the variable that has a coefficient of 1 is going to be the easiest one to do. All right, so anytime you have that present, then you want to make sure you pick that one. If there's no coefficient of positive 1, try to find one that has a negative 1. If there's no negative 1 present, then you have to look and see whose numbers are compatible with each other so that you don't have an abundance of fractions, because it is possible to end up with some very messy problems with fractions in them if you're not careful. All right, so, and sometimes one of your equations is ready to go to where you don't need to do step 1. It all just depends on your situation. All right, after you've done step 1, then step 2 is actually where this method gets its name from. All right, you are going to substitute the expression from step 1 into the other equation and solve for the other variable. This will get you half of your answer, because remember, your answers have to be written as an ordered pair, which means you need 2 values, so this will get you one of the values. All right, so now that you have half of your answer, we're going to have to substitute again. All right, so you see why it gets its name, but you're going to substitute the value from step 2 into the revised equation from step 1 and solve. And this will get you that second value that you need to complete your ordered pair. Right? And then the last step is, remember, like always, going to be the optional one, but you always have the option of checking your answer. Right? So if you wish to check the solution in both original equations, then that is your option. Okay, so really I would only recommend doing the checking piece if you're just unsure of your answer, or if you just really want to take the time and see, did you get it right? All right, so the way we're going to take and go through is some examples we're going to work out together. And with the examples, I'm going to put the system on the left side of your notes, and then all of the work will happen on the right. Right, so that you can see all the steps that go with it, because it is going to take up more paper space. This method is not super short, right, but it's not difficult to do once you get the flow of things. Right, so the first example we're going to do is negative x plus y equals 1 and 2x plus y equals negative 2. All right, so that's your system. Remember, for step 1, we want to pick one of the equations and solve it for one of the variables. So if you look at the 2 equations, they both have a y value. They have a positive 1 for a coefficient. So either one of them would be good. It doesn't matter which one you pick. It's going to come out the same way either way you go. All right, but always remember to pick whatever letter has a positive 1 coefficient, if at all possible. All right, so I'm going to take the first one of negative x plus y equals 1. And because I want to solve it for the y, that means the y is going to stay where it is, and I'm going to move everything else over. You're technically not putting it in slope-intercept form, even though it may look like it. We're not graphing, so there is no slope-intercept form when it comes to this method. It's just solving for a certain letter. All right, so I have to add x to make that happen. and now I get y equals x plus 1. Okay, this is what is known as your revised equation. And what you want off of this is the expression part. Expressions are everything without the equal sign. So everything behind the equal sign is known as your expression. That's what you're going to substitute in. So we use the first equation to do this. We're going to substitute x plus 1 in for the letter y in the other equation. So this x plus 1 is going to replace the y value in that second equation. So here's what you have left. You have 2x plus, now insert x plus 1 equals, and negative 2 was in the original equation. When you get to this stage of your work, you should only have one variable in your equations. If you have more than one variable, you know you did something wrong. And at this point, you're going to solve a multi-step equation like we've been doing since September. All right, so you have to combine your like terms. 2x plus x is going to make 3x plus 1 equals negative 2. And you've got a two-step equation, so subtract 1. This gives you 3x equals negative 3. Divide by 3, and you end up with x equals negative 1. So remember that your final answer to this system is going to be an ordered pair. And because we have the letters x and y, your x value will go first, your y value will go second. It's always alphabetical because you won't always have the letters x and y. So negative 1 is going to go in the x pot, and now we are ready to find whatever the y value is. All right, so the negative 1 that you just received as your x value is now going to come back up here to the revised equation, to that expression that you were doing, and that's what you're going to substitute in. So now you've got y equals, take the x out, put the negative 1 you just found in, and then plus 1. Negative 1 plus 1 makes 0. So the y value to this ordered pair is going to be 0. So your final answer is coming out being negative 1, 0. If you were to graph this, that'd be the point of intersection, but we didn't have to graph it. This method allows you to get your answer without ever making a picture happen. Right? Now, if you wanted to check, I'm only going to check on this one to show you what it would look like. Right? But then after that, I'm not going to show you what that looks like. You can do so on your own. So the first equation was negative x plus y equals 1. Well, if I put my values in, negative negative 1 plus 0 equals 1, negative negative 1 turns into positive 1 plus 0 equals 1, 1 equals 1. So it works in the first one. If you go to the second equation, you have 2 times negative 1 plus 0 equals negative 2. And that makes negative 2 plus 0 equals negative 2. So negative 2 equals negative 2. It worked in the second one. As soon as I see that it works in both, I know that the answer I got is the right one. Okay, so you can decide if it's worth it to check yourself, or you can just trust your work and see that everything comes out that way. Okay, all right, so let's do a couple more practice problems together so that you have some sort of confidence with this before you come to class, and we can practice some more in class. So the next system is 2x plus 2y equals 3, and x minus 4y equals negative 1. Right? And if you look for the easiest equation to get the letter by itself, the only one that has a coefficient of 1 is the x on the bottom one. So I'm going to take x minus 4y equals negative 1, and I'm going to solve it for the x, which means the x will stay, and I will get rid of everything else. So that means everything else goes to the other side. So to make minus 4y go away, I have to add 4y. So now this gives me x equals 4y minus 1, right? And remember, everything after the equal sign is your expression that you substitute in. It's going to go in for the letter x in the first equation because I already used the second equation. So this 4y minus 1 is going to go all the way up here in the spot of the x right behind that 2. So when you take and substitute it in, you're going to have 2, you have to put parentheses, 4y minus 1, and then close your parentheses, plus 2y equals 3. And notice I only have the letter y, so I know I'm doing it right. Now you got to solve your multi-step equation, and this is where it's going to be distributing and then combining like terms and then everything we've been practicing before. Remember, your final answer comes out in that ordered pair. Right? So after distributing the 2, we have 8y minus 2 plus 2y equals 3. Combine the like terms of 8y and 2y, so now you've got 10y minus 2 equals 3. Add your 2 over. So you have 10y equals 5 divided by 10, and 5 can't divide by 10, so when this happens, we leave it as a fraction. The fraction is 1/2. So 1/2 goes in the y spot of my ordered pair. All right, so now that 1/2 value, though, is going to be what I substitute in back up here into my expression to figure out my x. Okay, so now I get x equals 4 times 1/2 minus 1. And lucky for us, 4 times 1/2 works out nicely. Half of 4 is 2. And 2 minus 1 is going to give us 1. So the x value is 1. So when you put that in your x value spot, your ordered pair is the 1 and 1/2 values. Right? And if you wanted to check it, you could. It would work itself out. Okay, so that's what we're doing, is we're taking and substituting into equations in different ways to make the ordered pair happen that otherwise would be a lot harder to happen through the graphing method. Right, so for the next one, we're going to take 3x plus y equals 3 and 7x plus 2y equals 1. Okay, and you'll notice that the only thing that has a coefficient of a positive 1 is the first one. So I'm going to take that equation and I'm going to solve it for the y to make the first move. So the y is going to stay put. I'm going to get rid of the 3x by doing minus 3x to both sides. This gives me y equals negative 3x plus 3. Okay, and the expression part, which is right behind the equal sign, is what I'm going to substitute in. It's going to go in for the letter y in the second equation, because that's the one I did not use. You always go to the equation you did not use to plug it back in. So I've got 7x plus 2 parentheses negative 3x plus 3 is substituted in, equals 1. And now I'm going to do my multi-step equation work to come up with the answer for x. Remember, your final answer is that ordered pair. So after distributing, you're going to end up with 7x minus 6x plus 6 equals 1. Combine your like terms. 7x minus 6x is x, plus 6 equals 1. Subtract the 6, and you get x equals negative 5. So negative 5 goes in the first spot of your ordered pair. Now take the value of negative 5 and plug that back in for x in your expression right here. So now you have y equals negative 3 times negative 5 plus 3. You have to follow order of operations. So multiplying goes first. Negative 3 times negative 5 is positive 15. 15 plus 3 is 18. So the y value in your ordered pair is going to be positive 18. Okay, so that's another one to demonstrate the method for you. All right, and then the last one that we will do is not going to be everybody's favorite, but you do have to be able to handle it. All right, and the reason that it's nobody's favorite, not including me, is because it doesn't come out with the answers the way you want them to. All right, so if we have the letters 7g plus h equals negative 2 and g minus 2h equals 9. You notice that the letters aren't x's and y's anymore. So when you go to write your final answer, they have to be in alphabetical order, which means G has to come before H. Please be very careful. Don't do all of this work and get the right values and then put them in the wrong spot in your ordered pair, right? Because it's very painful to see when students do that, and you don't like seeing yourself do that either. All right, so the first thing we need to do is pick an equation. So I'm going to go ahead and take the first one and go for the H. So 7g plus h equals negative 2. Which means I'm going to get the h by itself, so I have to subtract 7g. And now I end up with h equals negative 7g minus 2. Okay, so my expression that I'll be substituting in is the negative 7g minus 2 part. That goes into the value of h in the second equation, the one we did not use. Right, so that looks like this. You will now have g minus 2 parentheses negative 7g minus 2 that you insert in equals 9. Okay, and again, we'll have to distribute. So we're distributing a negative 2. Be very careful about your signs. So this becomes g plus 14g plus 4 equals 9. Combine your like terms. 1g plus 14g is 15g plus 4 equals 9. Subtract your 4. So you end up with 15g equals 5. Divide by 15. 15 does not go into 5, so it does create a fraction. Reduce your fraction, so your final answer for G comes out being 1/3. So over in the ordered pair, right, you're going to put 1/3 as the first value, because that's your G value. Right? Then we're going to take, and to get the H, we're going to have to take our fraction of 1/3 and go all the way back up here to the expression and plug it in. Right, and here's where it can get a little bit messy. You've got h equals negative 7 times 1/3 minus 2. Okay, remember when you multiply a number times a fraction, you put a 1 on the bottom of it so you can go straight across. So now I've got negative 7 over 3 minus 2. Right? You can either use the calculator at this point, or if you know enough about common denominators, right, the 2 needs to be turned into a fraction that has a 3 on the bottom. So when you're looking at common denominators, the negative 7/3 stays what it is, but then the 2 becomes something over 3. Well, to get from 1 to 3, you have to multiply by 3 on the top and the bottom. So that becomes minus 6 over 3. And once you get to that part, you're just subtracting the top numbers. So negative 7 minus 6 produces negative 13, and the denominator stays 3. If you can't do that because you don't remember how, use the calculator to get that answer. Just make sure you use parentheses around your fractions. Right? So in the h value part of our ordered pair, it is negative 13/3. You can see why graphing method would not be a good one for this one. You have an answer, and this is the legitimate answer, but if we were to graph it, there's no way we could get accurately close to those values that are there. Okay, so that's when substitution becomes a better method to use because it is more accurate and it does get you that one and only answer that you can't see from graphing.